Okay, welcome to Solving 3x3 Systems, Part 2. This will, hands down, be the most difficult problem that we've tackled so far. If you've been working, if you're a little tired, I would suggest taking a little break. Maybe put your head down for 5 minutes, maybe get some coffee, maybe get an energy drink, whatever you have to do. But I want you to really prepare yourself for this problem. Take all the notes, and any questions that you have, I want you to throw them in the comments, and then I will answer the comments on YouTube. And if y'all have a bunch of questions, maybe y'all can help each other out that way as well. So let's begin to tackle this. Thing number one was the very first thing that I noticed. I noticed that we have a very gross equation right there. But I also noticed that this fraction has a denominator of 2. If you ever have fractions and they all have the same base, we actually have a pretty cool trick that I want to show you. So let's choose this to be our equation in blue. And I'll write it up here. It is negative 3 over 2x plus 7y plus 6z is equal to negative 31 over 2. And we want to make this a more simple expression. What can we do? Well, I notice that my denominators are 2's, and so I'm going to multiply by 2. Anytime you have the same denominators across the board, you can just multiply by that number and check out what happens. When our denominator and our whole number are the same, they can actually cancel, and so 2 times negative 3 over 2, it's just the remaining thing, which is negative 3x. Okay, what about 2 times 7y? Well, that's 14y, and 2 times 6z, let's see, that will be plus 12z. And check it out, now we have our cool little trick again. When the denominator and the whole number are the same, they cancel, and we're left with negative 31. Okay, so now we have this equation, and we're going to notice something that is very, very nice. We have this negative 3x plus 14y plus 12z is equal to negative 31. And, you know, let's put this one actually in blue, this second equation actually in blue. So here, I'm using this one in orange, so let's use the second equation in blue. Well, that is 3x plus 5y minus 9z is equal to negative 7. And what do we notice? Negative 3x plus 3x zeroes out, and now we can continue from there. 14y plus 5y is 19y. 12z minus 9z is plus 3z is equal to, and negative 31 minus 7 will give me negative 38. Okay, and we have our first equation. Whew. Alright, now I'm going to pause the video and do some erasing, so start taking your notes. Okay, so you'll notice we have our equation in orange, and that's going to be the equation that we're going to use for our top example. So we have minus 3x plus 14y. Remember, it's not the original equation, it's our manipulated equation, is equal to negative 31. Now, using this nice purple color, we are going to now try and tackle this equation right here. 2x minus 4y plus 2z is equal to 10. And I want to show you what our new problem is. Here's our new problem. We canceled out the x values here. We canceled out the x values. We have to cancel out the x values there. And you might be saying, Mr. Hastings, there's no number I can multiply negative 3 by to get to 2, and there's no number I can multiply 2 by to get to negative 3. So what are we going to do? Well, here we are going to find the LCM. So what is the LCM of 3, and what is the LCM of 2? Well, I know that, what are the multiples of 3? There's 3, 6, 9, and 12. And what are the multiples of 2? There's 2, 4, 6, and 8. And notice our least common multiple, our LCM, is 6. So when tackling this problem, what are we going to do? Well, I'm going to multiply this top number. Negative 3 times 2 will get me to a 6 value. And on the bottom, I'm going to have to multiply this whole thing by 3, because I know that 3 times 2 will get me to 6. And so basically, guys, this is that example where we have to multiply everything so that we can create a least common multiple to cancel. Okay, so I'm going to use orange for my top equation. 2 times negative 3x will give me negative 6x. 2 times 14 will give me 28y. 2 times 12 will give me 24z. And of course, 2 times negative 3 is negative 6. What about on the bottom? Well, 3 times 2x is 6x. 3 times negative 4 is negative 12y. 3 times 2z will give me 6z. And of course, 3 times 10 will give me 30. And what does this look like when I combine it all together? Well, I know that we have our zero pair right there. I know that 28y minus 12y will give me 14y. I know that 24z plus 6z will give me 30z. And of course, guys, negative 6 plus 30 is 24. And I now have my second equation. This is a lot. If you're not taking notes, you will not learn this. I'm going to pause this video. I want you to pause it as well. Finish taking your notes. And let's clean this up. Okay, y'all. Basically, this really gets us to where we were in our first 4 lessons. We now have a 2x2 system. This isn't too bad, guys. So here'd be my question to y'all. What looks like it's easier to get rid of? A 14 and a 19, or a 30 and a 3? Well, personally speaking, I think the best thing to do would be to multiply 3 by a number to get to negative 30. So that should be pretty easy. 3 times what number will get me to negative 30? Well, we would multiply by negative 10. So what would this look like? I do negative 10 times 19, I get negative 190y. I do negative 10 times 3, and I get negative 30z. I do negative 10 times negative 38, and I get positive 380, large numbers. And guys, now I just take this very top equation, I bring it down, and I now have 14y plus 30z is equal to 24. And from here, guys, we can go ahead and start combining the things that we know. So I know that negative 190y plus 14y is going to be negative 176, large numbers, I know. Negative 176y. Negative 30z plus 30z, well, that of course zeroes out. And here we have 380 plus 24, which looks like it's going to give me 404. Okay. And now all we have to do to get y is divide both sides by 176. Or by negative 176. Let's see what y equals. By the way, guys, sometimes there's a time for fractions. Sometimes there's a time for decimals. I would say that if this comes out to be a fraction, we should probably use a decimal. Yeah, this is a pretty gross number. So here, we're going to change this into a decimal. And we're going to say y is equal to negative 2.3. And guys, I only say that because if we were to use the fraction, it would make the math almost too unbearably hard. Okay, now recall, from here you actually get your choice. Do you want to use this top equation, or do you want to use this bottom equation? And guys, since I have that bottom equation in blue, just in an entirely different color, I'm going to go there. I'm going to say, you know what, 19y plus 3z is equal to negative 38. Once again, let me pause this video, clean it up, and y'all need to take y'all's notes as well. Okay, so what is y? Well, we know that y is negative, let me be able to write this, negative 2.3. And you guys, you probably need a calculator for this. Well, what's 19 times negative 2.3? Well, that's going to give us negative 43.7, okay, plus 3z is equal to negative 38. Well, guys, from here, I know y'all can do this. We simply add 43.7 to both sides, plus 43.7. That goes away. And now we have this. We have 3z is equal to let's see, negative 38 plus 43.7, which will give us 5.7. We can divide both sides by 3, and we can get this. Z is equal to 1.9. Okay, well guys, we know our y, we know our z, and we even have space, so let's just go ahead and solve for x. Once again, since I have purple and blue, let's just go ahead and choose this equation that I have in, you know what, let's not choose that one. That would be the grossest equation to choose. Let's use this one right here, and I'll just rewrite it in orange this time. We'll say, okay, 2x minus 4y plus 2z is equal to 10. Well guys, what is y? I know that my y value is this negative 2.3. I know that my z value is going to be this 1.9. And from here, guys, we can say, you know what? We got 2x minus, let's see, a negative times a negative is a positive, and 4 times 2.3 will give us 9.2. Oh, 9.2 plus 2 times 1.9, which will give us 3.8, is equal to 10. Well, check it out, guys. I know that 9.2 plus 3.8 will give me 13, which is equal to 10. And wait a second, now we actually have some normal, nice numbers. 10 minus 13 gives me negative 3. I divide both sides by 2, and it looks like x is equal to negative 3 over 2. Alright guys, remember to finish this problem off, we simply have to write our point where we have our x, our y, and our z. And so our final answer will be this. Oh, and you know what? Let's write negative 3 over 2 as a fraction. Or I'm sorry, as a decimal. Negative 1.5. Negative 2.3. And z is 1.9. And there we go. There's the most difficult problem that we've completed so far to date. And guys, it really does not get that much harder than this. If you can do this, you can do anything.